Hi guys, so now that we've got our basics in our fundamentals kind of learning unit taken care of, we're going to move on to our first biomolecule, which is to really think about nucleotides and nucleic acids. And so what's really exciting about this chapter is actually we will spend a good bit of time going off topic from what's in your textbook, and that's just because this field is advancing so rapidly. So we will spend a little bit of time talking about the building blocks, not only to make things like NTPs, but how those get connected together to make DNA and RNA. We'll talk a little bit about the structure-function relationship there. We'll spend a little bit of time, too, talking about the direct use of some of these nucleotide triphosphates, like the molecule ATP, which we've spent some time already talking about. But we'll also spend some time talking about some nucleotide derivatives, like FADH2, NADH, and acetyl-CoA. And that will bring in our first discussion of some of our B vitamins, and we'll talk about vitamin B2, vitamin B3, and vitamin B5. So, but again, most of the time is going to be spent talking about kind of where this field of genomics has moved in recent history. And so to provide a little context, about 15 years ago in 2003, the Human Genome Project was completed, and we basically had 3 billion pieces of information and didn't have a lot of knowledge about how to use that information in a productive way. So actually 3 days prior to me making this video here, the NIH, the National Institutes of Health, put out a report on the future of genomics research. So we're actually going to talk about a significant number of those in a couple of days we'll spend on this chapter. We'll talk about kind of what are the next steps in genomic research. We'll talk about things like SNPs, which are SNPs, or single nucleotide polymorphisms, and the HapMap project. So how can we use that data in a meaningful way? We'll also talk about the ENCODE project. So as much as we have these 3 billion pieces of information, unless we know what it does, what it encodes, then it's not really useful information. We'll spend a little bit of time talking about pharmacogenomics, which is the aspect of how does your genomics, how does your genetic information influence how you metabolize drugs. And that, of course, has a lot of significant implications in individualized treatments for diseases like cancer. And then we'll talk a little bit about genome editing and talk about kind of the CRISPR-Cas system, how that works, and then we need to also consider ethical implications of the ability to edit the human genome. What does that mean, and what's the future kind of that field of research? So many of you are interested in going into the medical profession, and so I think it's important to recognize that the future of medicine is probably going to be individualized, and because what makes us individual are our genetic differences, kind of having an understanding of this is going to be a really critical part in that story.